Okay, let's approach this problem very systematically. Y is going to equal a cosine of omega t plus theta naught because we chose the cosine model. V of 0 equals 2 meters per second. That's from the uppercut. K is 2,000 newtons per meter. That was given, as was the 5 kilogram mass. We see K and M. At every opportunity we use the fact that omega equals square root of K over M. So that's going to be what? Square root of K over M is, that's 2,000 over 5, which is 400. The units will be reciprocal seconds squared. If you divide the Newton by kilogram, you're going to end up with a meter squared per second squared. Divide out the meter, you end up with a second squared in the denominator, etc. So this is going to be square root of 400 seconds to the negative 2, which is 20 radians per second. So now we're going to have y equals a cosine of 20 radians per second times t plus theta naught. Now, y prime, that's our v function, y prime is omega a cosine of omega t plus theta naught, which equals 20 radians per second times a. Now when we multiply out the radians per second by a, once we get a value of a, it's going to be in distance units. So we multiply those distance units by the distance by radians, and we're going to get arc distance. So that's going to convert to the radian will become the distance unit. And then that's going to be times the cosine of 20 radians per second times t plus theta naught. Since v of 0 equals 2 meters per second, we get v of 0 equals 20 radians per second times a times the cosine of what? 20 radians per second times t. Well, t is 0, so that's going to be theta naught. So v of 0 is 20 radians per second times a times the cosine of theta naught, and that's going to equal 2 meters per second. And I've got a bonehead error there. I'm going to have to fix that. Took the derivative and I just wrote down cosine without thinking, and I didn't write in my negative sign, so let me fix it. Okay, so I've changed my cosines to sines, and I've introduced the negative signs in each step. So we have this, which tells us, I'm going to leave it in this form. We have two unknowns. We have a and theta naught. We have another initial condition. We have that y of 0 equals 0, which implies that that a cosine of omega t plus theta naught is 0 when t is 0. So that implies that a cosine of theta naught equals 0. And the only way that can be is if theta naught is an angle that makes the cosine 0, because a can't be 0. So cosine theta naught equals 0, and you have two solutions to that. Theta naught equals pi over 2 or 3 pi over 2. We're going to be doing calculus with this. We don't bother with degrees. Degrees would result in horrible, well, not horrible, but very inconvenient conversion factors that we don't want to deal with. So we're going to go to radians here. So it's pi over 2 or 3 pi over 2. Remember that radian is the default unit of angle, in mathematics, so we don't have to write radians. Pi over 2 means pi over 2 radians in this context. Okay, so theta naught has to be one of these angles, and we have this equation. So you should pause and tell me what you think theta naught has to be. Should it be pi over 2 or should it be 3 pi over 2? Okay, well, I'll write this out just to make it clear. Negative 20 radians per second times A sine of theta naught equals 2 meters per second. This is negative. The only way this is going to be negative is if the sine of theta naught is negative. So sine of theta naught must be negative. From that we reject theta naught equals pi over 2. Theta naught is got to be 3 pi over 2. So again, now we have negative 20 radians per second times A sine of 3 pi over 2 equals 2 meters per second. Sine of 3 pi over 2 is negative 1. That tells us that 20 radians per second times A equals 2 meters per second, so that A equals 2 meters per second divided by 20 radians per second. Now, work out what that is. I'm going to write it down here in a second, but you need to pause and figure that out if you possibly can. So we conclude that A is 2 meters per second over 20 radians per second, and that equals, well, 1/10 or 0.1, and it's going to be meters over radians equals 1/10 of a meter, because for the same reason that when you multiply a meter by a radian you can get meters, multiply a meter of radius by radian of angle, you get a meter of arc length. If you divide a meter of arc length by the angle, you get a meter of radius. And the amplitude corresponds to the radius of the unit circle, so that all works out. And of course that could be 10 centimeters. So we now know the motion of this oscillator. Okay, so y equals A, which is 10 centimeters, times the cosine of omega t. Omega is 20 radians per second, times t, plus 3 pi over 2. Now we're going to ask a question in which the theta naught is not going to be is not going to indicate an angle that's a multiple of 90 degrees. We're going to adapt this to see what we can do with that theta naught.